Today we're going to continue to learn about motion. Now what I want to start with today is a famous physicist by the name of Sir Isaac Newton had 3 laws of motion. And today we're going to learn about the third. His law says that for every action, there's an equal and opposite reaction. What does that mean? Well, I have a marble here. If I push the marble's going to move. The action was me pushing the marble. The reaction was the marble moving. Now what if I take the marble and I drop the marble? The action was me dropping the marble, gravity pulling it at the same time, and the marble, it bounced on the table. It hit the table and reacted. The table was pushing back at the marble. There was a reaction. Before we get started with the lab, I want to start off with a quick little demonstration. Right here, I have a cup with just a little bit of water, and I have some Alka-Seltzer tablets. Now, Alka-Seltzer are tablets that adults may take if they have a little bit of a tummy ache, but they're actually wonderful for science experiments. If we take one of these tablets and drop it inside of the water, let's see what happens. There's a lot of fizzing. There's a lot of bubbles being created. Now those bubbles are gas bubbles. Now you may wonder, what does that have anything to do with motion? Well, let's do an experiment that shows us how those bubbles and those gas particles that are being created can create motion. They can create an equal and opposite reaction. I have a container here. This is a film canister. I'm going to open it, and I'm going to pour water in about halfway. And then in a minute, what I'm going to do is take my tablet, break it into a few pieces, drop it in, and quickly cap it. And then let's see what happens when I do that. Okay, I have my tablet. Going to break it up, drop it in, quickly flip. Whoa, did you see that? That was fast. Let's watch it again. Well, that was fun, right? What did it remind you of? Kind of like a rocket, right? This film canister, we turned into a rocket, but how did we do that? So just a little bit of water, and we added the secret ingredient, which was the Alka-Seltzer. And you saw what the Alka-Seltzer does. There was bubbling and fizzing and all these gases being created. Well, those gases, for every action, there's an equal and opposite reaction. Those gases took up so much space that caused this lid to pop off and kind of look like a rocket, kind of like a real rocket that you may see. And our secret ingredient was the Alka-Seltzer, which was kind of like the fuel for the rocket. Now, what we're going to do together is we're going to build another type of rocket. From your enrichment bag, you're going to need 2 items. You're going to need a Kool-Aid juice bottle that's empty. You're going to need 1 big clear straw. You're going to need one thinner green straw, and you're going to need some clay. Again, here are the items that you'll be using for this lab. An empty Kool-Aid bottle, 2 straws that are different sizes, and a little bit of clay. The first thing I want you to do is take your juice bottle, give it a gentle squeeze, and see what you feel. What do you feel in there? Something is inside of this bottle that when you squeeze it, you feel it on your hand. You may say there's nothing in here, but there's something in there. And that's going to be our secret ingredient today, air. There's air inside of this bottle. The first thing you're going to do is you're going to take a small amount of clay and roll it into a little snake like this. Mine's even a little too big. I'm going to take some of it off. And I'm going to take my green straw. Now, the one thing I want you to notice is the green straw has nothing on this end and nothing on this end. It's completely hollow all the way to the other side. And that's important that we keep it like that. The other thing I want to mention is one straw very comfortably slides through the other straw. Do you notice that? Try it again. Very easily. So now you're going to take your green straw and making sure it doesn't fall into the juice bottle, you're going to hold it and you're going to just insert it inside the juice bottle, just a small amount. And then you're going to use this piece of clay it has 2 jobs actually. This piece of clay is going to hold the straw in place, which it's doing right now. But the other thing that we're going to do is we're going to close any holes that there may be. We're going to plug up any air gaps that there may be so that the air doesn't escape from the sides, but the air only comes out from one side. Just take a few minutes to gently press on it. You don't want to overly squeeze it because then it'll make it warm and it kind of changes the clay. It makes it a little bit watery. So now that I have secured it, again, I'm going to give it a gentle squeeze and see, well, now I still feel the air coming out, but the air is now coming out of my straw. If you don't feel air coming out of your straw, then you've done something wrong. Then that means that your green straw might be plugged up. So go ahead and disassemble, clean it up, and reassemble. So remember, we want to feel the air. Then now you're going to take another small piece of clay, and this one you're going to flatten. And now you're going to take your other straw and you're just going to poke it through the clay like that. Now you'll notice one side of my straw has a plug, the other side does not. I'm going to take my straw, the side that doesn't have a plug, I'm just going to slip and slide it right over my rocket, right over my other straw. Now you notice I didn't push it in gently. I can slide it in and out. And now my rocket is ready. What I have to do now is just test it. Now that I have my rocket assembled, remember, you want the top straw to slide very gently. I'm not going to push it in. You want to go to a space that is kind of open. You don't want to point this at anybody, and you want to be away from any big objects that are around you. Now what you're going to do is you're going to test this rocket two ways. Remember, for every action, there's an equal and opposite reaction. Well, what does that mean? See what happens if I squeeze my rocket with a gentle squeeze, with a small squeeze. There was a reaction to my action. I gave it a squeeze and the rocket went flying. Did the rocket go really far, or did it go a small distance? Well, to be able to answer that, we have to now give it a big squeeze and see what happens there. Now, I'm going to give it a big squeeze. And let's see how far it goes with a big squeeze. Whoa, it went so much further. It went flying. I gave it a big squeeze, so it went a further distance. Remember, small squeeze went a small distance. Big squeeze went a big distance. Let's watch it again.
To do this again, I came outside so I could have a little bit more space. And now I have my rocket. I'm going to give it a small squeeze, and I'm going to watch and see where it lands. Okay, let me go mark that so you can see where the small rocket landed. You can see my neon green posted on the floor. That's for my small force. Now we're gonna try it again, giving a big force, and see if it goes further or if it goes a shorter distance. Whoa, wow. Let me go mark that one. Can you see the difference? This is the small force. And let's count how many feet it took. Wow. How many feet further is it? Let's count. 1, 2, 3, 4, 5, 6. 6 feet further the rocket went when there was a big force.
So just to review what we did today, we constructed rockets out of very, very simple, basic recyclable materials at home. Juice bottle, some straws, and a little bit of clay. Now we built one rocket, but we tested it a few different times. The one thing that was different each time was the force that I applied. I gave it a small force and I gave it a big force. Now remember what Newton's law said. For every action, there's an equal and opposite reaction. Equal. Well, if I gave it a small force, it went a small distance. If I gave it a big force, it went a bigger distance. Go ahead and try this. Can't wait to see your results.